lesson is 4.4. We are talking about parallel and perpendicular lines. As you can see, we have a very special guest to help us out today with this lesson. It's your assistant principal, Mr. Van Scoy, and hopefully you'll learn a thing or two from him today about parallel and perpendicular lines. Do you know anything about parallel and perpendicular lines right off the bat?
Oh, I know a few things about parallel and perpendicular lines. I always think parallel looks like this, perpendicular looks like this.
That's awesome. Let's get started. Previous objective was to write equations in slope-intercept form, and two objectives for today is to write an equation of the line that passes through a given point, parallel to a given line, and perpendicular to a given line. So make sure to pause the video and make sure you get the objective in your notes, as well as new vocabulary words. So two main concepts: parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes. So before we get started, let's go through the concept summary of parallel and perpendicular lines. A couple visuals for you. Parallel lines will never ever intersect, and they are parallel if they have the same slope. Perpendicular lines cross at 90 degrees, and two non-vertical lines are perpendicular if their product of their slopes is -1, also known as opposite reciprocal. So before we get started with the examples, Mr. Van Scoy is going to help us identify the parallel and perpendicular slopes for each one of these equations. So the first example, I have y equals 3x, and as we know, our slope is 3. So Mr. Van Scoy, what would my parallel slope be for this equation?
Wouldn't it just be 3?
Right, it is the exact same. So for a different equation, a parallel slope would be 3. What would the perpendicular slope be of 3x?
-1/3?
-1/3. The reciprocal of 3, or 3 over 1, is 1/3, and the opposite, making positive, changes it to negative. If it was negative, we change it to a positive. So the next example, I have -6 for my original equation. What would the parallel slope be of my new line?
I think it's just -6.
Right, it's -6, the same slope as my original. If I want a perpendicular line, my slope would have to be
+1/6.
+1/6, the opposite reciprocal of -6. How about 2/3? If my new parallel line, what would my slope be for this?
Well, the same as your original slope, right? Which is 2/3.
2/3, so my perpendicular line would have to be?
-3/2. Is that what I say?
Yeah,
or
that would work.
3/2?
3 over 2 works. Yep,
3
they all
over
work.
2.
Yep.
Excellent.
All right, my last one, -1/5. A parallel line would be?
That would be -1/5.
-1/5, and a perpendicular line would have to be?
Well, I would think it would be +5 over 1, but that's just 5, right?
Yep, 5 or 5 over 1 works as well. They are both the same thing. All right, so let's get started. Example number 1, parallel line through a given point. Write the slope-intercept form of an equation of a line that passes through -3,5 and is parallel to the graph of y equals 2x minus 4. So the first thing that I'm going to do is just identify my x equals -3, my y equals 5, and then if it's parallel, what is my slope going to be for this equation?
2.
2 is correct. We are going to use the point slope method because that is the method that we use given an x and y as well as the slope. So we're going to put it into y minus 5 equals my slope of 2 times x minus a -3 becomes x plus 3. Now they want it in slope-intercept form, so I am going to do the distributive property, very similar to lesson 4.3, and we are going to convert point slope form into slope-intercept form. So it becomes 2x plus 6, and then my last step is to add 5 to both sides. So my equation is y equals 2x plus 11. So what we just solved was an equation of a line that goes through -3,5 and is parallel to y equals 2x minus 4. All right, the next one is a checkpoint. You can go ahead and pause the video if you would like to and then check your answers with mine. Otherwise, you can go through another example with us. All right, we are going to get started. So my x value is -4, my y value is -1, and my slope for this equation, if it's parallel, Mr. Van Scoy, would have to be?
1/4.
1/4 is correct. So again, point slope form, y minus a -1 becomes y plus 1. My slope is 1/4 times x minus a -4 becomes x plus 4. Again, now I'm just converting point slope form to slope intercept form. So it's y plus 1 equals 1/4 x, and then 1/4 of 4 is 1. And my last step is to subtract the 1 from both sides, and I get y equals 1/4 x plus 0. Or we don't need the 0. If you want to add it, you can. Otherwise, you don't have to. The y-intercept would be 0. All right, one more example here. My x equals 2. My y equals 3. And Mr. Van Scoy, help us out again. What does my slope need to be for this equation if it's parallel?
1/2.
1/2. Point slope form, y minus 3 equals 1/2 times x minus 2. And then again, point slope to slope intercept would be y minus 3 equals 1/2 x, and 1/2 times -2 is -1. Add 3 to both sides, and my equation is y equals 1/2 x plus 2. All right. Next example is parallel and perpendicular lines. Determine whether the graphs are parallel or perpendicular. My hint to you is that in order to tell whether or not they have the same slopes or the opposite reciprocal slopes, we need to put them into slope-intercept form. We have 3 equations here. We have the first equation, we have this second equation here, and we have this third equation here. So we're going to see if any of them are parallel or perpendicular. My first one, y minus 3x equals 12, I need to put it into slope-intercept form. So I'm going to subtract an x from both sides. I get 3y equals -x plus 12. Divide everything by 3. And I get y equals a -1/3 x plus 4. So that's my first example, or my first problem. My second problem is already in slope-intercept form, and it's 1/3 x plus 2. And my third problem, 2x minus 6y equals a -18. I'm going to subtract the 2x from both sides. I get -6y equals -2x minus 18, and divide everything by a -6. You can tell I'm writing too fast because my pen is glitching. Y equals a positive 1/3 when it's simplified, x, and then a -18 divided by -6 is positive 3. So again, what they want you to do is determine which ones are parallel and perpendicular. So we have a -1/3 x, we have a positive 1/3 x, and a positive 1/3 x. So your answer would be that number 2 and number 3 are both parallel if they're same, correct?
Yep, they're parallel.
If it's -1/3, this is not perpendicular and it's not parallel to 2 and 3. So again, you're identifying which out of the 2 or 3 equations are parallel and or perpendicular.
What would have made it perpendicular, Miss McKissick?
Well, the opposite reciprocal of 1/3 would be -3.
Ah.
Okay? So we are to your multiple choice question, and Mr. Van Scoy is going to help read this one for you.
All right, so we're going to determine whether the graphs of y equals -2x plus 1 and x minus 2y equals -4 are parallel or perpendicular.
So again, just like we did in the last example, you are going to put them into y equals mx plus b form and see if their slopes are the same or the opposite reciprocal. All right, the last example is parallel and perpendicular lines. So it says write an equation in slope-intercept form for the line that passes through -4, 6 and is perpendicular to the graph of 2x plus 3y equals 12. I wrote down some steps here, missing step number 1. Find the slope of the given line. First of all, you need to put the equation into y equals mx plus b because we need to figure out what that slope is. Then you are going to use, just like you did in example 1, point slope form to put your new equation into slope-intercept form. So I wrote this exact same problem on the next slide here. All right, so the first thing that we need to do, all right, unfortunately the bell had rang and Mr. Vanscoy had to leave, so we're gonna finish up with example 4 here. Write an equation in slope-intercept form for the line that passes through -4, 6 and is perpendicular to the graph of 2x plus 3y equals 12. Now I stated the steps in the previous example, but the first thing that we need to do is take 2x plus 3y equals 12 and put it into slope-intercept form. So I'm going to subtract 2x from both sides. I get 3y equals negative 2x plus 12, and then divide everything by 3. So the first step is to put it into slope-intercept form. Y equals negative 2/3 x plus 4. So step number 2 is to identify your points. I have x equals negative 4, I have y equals 6, and I have m equals, if it's perpendicular to my line of negative 2, 3, then my slope, if it's perpendicular, would be a positive 3/2. We're going to use the point slope form. So y minus 6 equals 3/2 times x minus a negative 4 would be x plus 4. I have y minus 6 equals 2/3 x, and then 3 times 4 is 12, divided by 2 is positive 6, and then my last step is to add 6 to both sides, and I get y to equal 2/3 x plus 12. So again, write an equation in slope-intercept form for the line that passes through. So this was my original line, and now this line passes through the point -4, 6, and is also perpendicular to my very first line. So let's go through one more example. This example is nice because the equation that they give us is already in y equals mx plus b form. So y equals 3x plus 5 is my first equation. My second equation, now I'm going to identify my points. I have x equals 3, y equals 6, and if they want it parallel, then it's going to be the exact same slope, which in this case is 3. So y minus 6 equals 3 times x minus 3. I get y minus 6 equals 3x minus 9. Add 6 to both sides. And my parallel equation is y equals 3x minus 3. So this first equation is parallel to this line. Notice how the slopes are exactly the same. And my second point goes through the equation 3, 6. Open-ended question. Make sure you get it down in your notes. First of all, translate the equation into y equals mx plus b. Then use the point slope equation to figure out your second equation that is perpendicular to the first equation. All right, that's it for today. We will see you tomorrow.